Hey Ryan, sorry couldn't meet during office hour today. If you have any questions, feel free just when we get started, just let me know. We can go over any problem.
Oh yeah, it's all good. Thank you. I
Yep.
actually do have a quick question on the homework.
Okay.
I think it's question 7. It's a logarithmic function. I don't really know how to find the domain.
Okay. Okay. We can definitely take a look at that.
Awesome. Thanks.
Yep. All right, let's see. I'm going to open a breakout room for William, and I'll just need to talk to him very briefly, and then I'll be back. Just hang around. All right. So, all right, William. Will, can you join the breakout room? Ready to take a quiz?
Hey, yeah, I can take it right now.
You can take it right now. All right, hold on.
Yeah, sorry, I didn't get back to you.
No problem. I'm just going to spend, probably the first half of the class reviewing. So whenever you finish, just come back to the main group.
All right, that sounds great.
All right, let me just let's see. If you go to quiz 2 on the pages, do you think you can open it?
Yeah, let me look right now.
Yeah, and let me know. I don't know if it's locked. It's like on the pages, if you click on
yeah, I got it.
You are able to see the problems?
Yeah, I got it.
All right, yeah, just work on it, and then when you finish, let's see, maybe let me open the submission. And, all right, so it's 6 o'clock. I would say finish everything and submit it by 7. Is that okay?
Yeah, that works perfect. Thank you so much.
Should be plenty of time.
Yeah, that should be great.
All right, good luck. And I'm just going to go through the review problem student might have, but it will be recorded. So you might have to, watch the recording or look at the lecture notes for the half of the time that you missed.
All right. Yeah, that works.
All right, good.
All right. Thank you. I'll join back when I'm done.
Yep. So you have until 7. I think that should be good now. Okay.
All right. Sounds good. Thanks.
Yep. Sorry, I was muted. So sorry about the delay. So today we're just going to review. So if you have any questions, I know that a few students was asking to see me during office hours, but I had a conflict, which happened. It's probably not going to be the last time. I apologize for that. But like I said, to those students, I'm going to use the class time to review. So if they have any questions, they should ask about them. And if for some reason, you have your questions, but that's not addressed during this class time, I know we can definitely try to make an appointment on a different time to address those issues. All right, so let's see. So Ryan had a question earlier about homework problems. So let me take that homework problem, homework 3. So there was a question says, Ryan, correct me if I'm wrong. The numbers might be different. It says f of x equals 4x plus 3 is a linear function. You might see a different number, but the g of x is a natural log function, and the A says find g of f of x. Is that correct? Well, let me take a screenshot of what I see for my number 7.
Sorry, I was looking it over.
Oh, no problem, no problem. Let me just copy paste, make it easy. Is this sort of the right question you were asking about?
Yeah, that's the question. So I managed to find f of g of x. I really didn't know how to go about finding the domain, especially where I really didn't know what that ln meant. And so I was just kind of in the dark.
Right. Okay, no problem. Yeah, good. So excellent. So you found g of f of x. I'm going to use my example. So again, the numbers might be a little bit different. So let's see, g of f of x. We're going to take f, put in the g. So we get natural log parentheses 6 times the x will be replaced with whatever f of x is, 4x plus 3. So that's going to be natural log, distribute the 6 into the parentheses. So note that this part is what f of x is. So distribute the 6, we get 24x plus 3, 6, 18. You should get something like this. Excellent. So next we need to find the domain, right? So the domain of composition functions, we have to do a few things. The first thing we need to find is we want to find domain of inner function, which is going to be the function of f of x. That's the function we put into G. So inner function in this case is f of x. So we know f of x is a linear, so the domain is from negative infinity to infinity. The second step, we have to find the domain of the new function that we found. Well, it's a natural log, right? So ln means natural log. Let me just kind of quickly draw a graph for natural log of x. It looks like this. This is a y equals natural log of x. This point is 1, 0. And if we have, let's say, log base 2 of x, it's basically have the same shape. It might go through a different point, but the 1, 0 is always a point on natural logs or logs with a base. That's not e. So I probably should emphasize that. Natural log of x literally means log base e of x. It's just the base is e, which is a number that's about 2.7. So e is 2.7. And so kind of like a pi, which is a convenient number that used a lot in mathematics. So that's natural log. But the one thing to remember about natural log functions, so for natural log functions, y equals natural log of x, or something that's not just x, the domain is always going to be from 0 to the right, but does not including 0. So the domain is going to be 0 to infinity. So the number, whatever goes into the parentheses part has to be positive. So must be positive. Doesn't matter, it could be natural log, could be log base 2, could be log base 5, or just log base 10. Any base, so whatever inside the log, the parentheses part has to be positive. So in this case, I think you should be fine now, because we need to have the new function is natural log 24x plus 18. We need to have 24x plus 18 to be positive. So we can solve for x from there. So minus 18 on both sides. So 24x greater than negative 18 divided by 24, x greater than negative 18 over 24. We probably should simplify this, divide by 6. So that's x greater than negative 3 over 4. So that's a domain of the new function. If we write it using interval notation from negative 3/4 to infinity. But then we have to look at, is there anything we need to exclude from the inner function? Well, the inner function says it's from negative infinity to infinity. This one says from negative 3/4 to infinity. So if we look at those two intervals, we just take whatever the intersection, the overlap, that will be the domain. It turns out to be the same as the domain of the new function. So the overlap of negative infinity to infinity and negative 3/4 to infinity will be the domain of the compensation function.
That answers it. Thank you.
Yep, no problem. I apologize if you you know, obviously we haven't talked about log functions yet, but it's somehow for this homework, you know, they just decided to throw it in there. I'm glad you asked. What would be the domain?
Will logarithmic functions be on the exam? Is it something I should refresh myself on beforehand?
I don't think so. To be honest, other than just for the homework, right? I would say don't worry about you know, seeing problem like this on the exam. If it is, I'll probably tell you enough information so that you will be able to figure it out. Good question.
Okay, thanks.
Yep. G of X. All right, that's a good question. So that's a homework that's a homework problem. Again, anything that we talk about so far could possibly be on the exam, right? So good question. Let's see, Alia, I probably didn't pronounce it right. You have your hands up. I'm sure you have a question. Go ahead, please.
I just have a quick question. So I know in the future, if we have a question about the homework, there's a feature that says like, ask the teacher, like, do you want us to write a note there?
Yes, actually, good point. That's a very good point. I know that the first homework, there was people asking questions, but I didn't get to them in time because I did not set up the notification through email. I fixed that problem. So now if you, you know, from now on, if you submit ask your teacher the question or ask for extension or whatever, communication right through the website, I should get an email notification immediately, and
Okay.
I'll try to get back to you ASAP.
Okay, thank you.
Yeah, but that's a very good point. I'm glad you brought it up. All right. All right, any other questions? I'm sure there are more questions. Please feel free to ask questions because I know that at some point, so I'm waiting for one student to complete quiz 2. So at some point, I'm going to go through quiz 2 problems with you. If you have questions specifically about problems on quiz 2, you know, like those 3 problems, we're going to look at them. Don't worry too much about it now. But if you have like other questions about previous homework or quiz 1, or like examples we did in lectures, please feel free to ask them. Whatever you feel confused about, I'm sure you are not alone in this situation.
Wasn't there another example for the compounding functions that you had wanted to go over today?
Yes. Thank you for the reminder. Excellent. Yes. So let's see. There was a problem about exponential decay. I was going to put in there. Last time I didn't forget, but thank you. I'm going to go through that. Then maybe I'll go through another examples with compounded interest just to review a bit. So recall continuous growth or decay. So has a formula. So if it's continuous, it has a formula A of t equals p times e to the rt, and r is the continuous rate, t is the time, and both of them in the exponent, and e is the base, which is just a natural number, and a p is the initial value. So p is initial value. All right. So the example I had in mind was, so suppose we have, let's see, some radioactive substance that decays over time. Let's see, we have 10 milligrams radioactive substance that decays at a rate of, let's say the rate is 0. It doesn't matter, 0.34%. Even though it doesn't say it's a continuous rate. So here, whenever we talk about exponential decay, we're going to assuming it's a continuous rate because it's always decaying, right? And I also should point out that the t usually is just in years, so you don't have to worry too much about the t being a different time. So decays at this rate. And the first part of the question says, let's see, how long, nope, not how long, how much will be remaining after, let's see, 5 years, maybe 50 years, right? So that's the first question. So, okay, how do we solve this problem, right? So we begin with 10 milligrams and it decays at this continuous rate, 0.34%. And we want to know, okay, 50 years later, how much of this substance is still around, right? So, well, first of all, we want to begin with some equation. So we begin with the general formula, which says A of t equals P times ERT. I always, this is a kind of a habit of mine. I always begin with the general formulas and I'm going to throw in what I know and then write down a new formula for this specific example. So let's see, what do we know? We know that the initial amount, the starting amount is 10 milligrams, and we also have the rate 0.34%. Okay, let's put those two numbers in there. Don't worry about solving the problem yet. So we put in there, we get A of t equals P, which is 10 milligrams times E. R is 0.34%. We have to convert that into decimals. So that's a 0.34 divided by 100. And if you're comfortable with it, so we just move the decimals to the left by 2 digits. So 0.0034. So that's 0.0034. That's a rate to the t. Okay, so now we get a formula that will give us the amount of substance remaining after t years, right? So that's pretty good. And we can use this to answer the question. It says, how much will be remaining after 50 years? Okay, so now we know that time is 50. So if we take time equals 50, put into this formula, all we're looking for is A of t. the amount that's remaining. So this tells us, so this gives t equals 50. We can put it in there. And if we do that, we get A of t equals 10 times e to the 0.0034 times 50 in the exponent. So if we put in the calculator, we have to be careful. This product is in the exponent. And then put in the calculator, which that should give us a number. Let's see, I don't have a calculator. We're just going to leave it the way it is. Any questions on this example? Okay, awesome. Now, the next example I have, so let's see, how long does it take for, let's see, 5% of, how long does it take for 5% of the substance to be decayed? So what that's saying is that we want to know a time so that 5% of the substance is gone now. So we need to figure out how much is remaining, right? And we want to know how long it takes to get to that point. Because all we know is that 5% is already gone. So let's see, let's find out how much is remaining. So amount remaining is going to be the remaining of whatever we begin with. Well, 5% is gone. So you can either think about, okay, 5% is gone, that means 95% is remaining. Or you can think about, okay, I'm going to take the 10 milligrams minus 5% of 10 milligrams. So both ways works. So amount remaining, A of t is equal to, like I said, you can either think about 10 milligrams, that's what we start with, times 95%, 0.95. That should give us the amount that's remaining. Or you can think about is A of t is equal to 10 milligrams, that's what we start with, minus what disappeared, which is 5%. So that's a 10 times 0.05. Either way should give us the right number. So that's going to be 9.5 milligrams at the end. That's remaining. Okay, so now we know how much is remaining, but we want to know how long does it take to get to this amount, right? So we're going to take the same formula we had in part 1. And then now we don't know the time, but we know how much is existing. So we're going to take this amount, put in there to replace A of t. So the amount existing is 9.5, and then that's equal to 10 times e to the 0.0034 t. And we can try to solve for t. And I just realized that you're probably not going to have this problem until we talk about logarithmic functions. But I just want to show you how to solve it. Don't worry about this specific second problem on the exam, because it actually requires logs to solve it. But anyway, I'm going to finish solving it no matter what. So let me just note, don't freak out. This is solving this is not solving it will not be on the exam. All right. So what we're going to do to solve it, we divide by 10 on both sides, because we need to isolate the t. So we get 9.5 divided by 10, that's a 0.95, which is equal to, that's going to be 1. So that's e to the 0.0034 t. Now, the next thing we need to do, if you remember in previous classes, if we want to solve for t in the exponent, we have to get rid of this e. So what we do next is we're going to add natural log on both sides, because natural log and e, they kind of undo each other, the base e. So left side, I get natural log 0.95. The right side, the natural log and the base e, they cancels, give us a 1. I always think about them as like a square and a square root. You know, if you have them together, they go away, right? because they undo each other. So now we just have whatever the exponent is, 0.0034t remaining. And the natural log of 0.95 is a number. Just think about if we put it in the calculator, we can get an estimation. So that's a number. And that's equal to a number times t. So we just divide by this 0.0034 on both sides to get t. So t equals natural log 0.95 divided by 0.0034. And if we have calculator, we can put it in the calculator, but I don't have it handy, so I'm gonna leave it there. All right, anyway, I just want to go through that process because eventually, we're gonna have to do this, but it's good to kind of show you and perhaps as a review for some of you if you've seen it before. Like I said, it will not be on the exam, so you don't need to worry about solving equations like this. Well, hopefully it wouldn't be there. All right, any other questions?
Oh, we're not allowed a calculator on the exam, just like the quizzes, right?
Good point, because that's a good point, because I was just thinking about what we did yesterday with the compounded interest. Let's just put it this way. If I say do not use a calculator on the exam, that means all the problems you don't really need to solve for any like weird numbers. So all the numbers either work out really well, or you're just going to leave it in a certain form that you don't even need to solve for anything at the end. Like you might just leave it as an expression. Like what I did at the first part here, I just leave it in this way because I'm not going to use a calculator. So that would be okay.
All right, so no calculator.
I don't know. I haven't decided yet.
All right.
But good point. Yeah, I'll put it in the instruction. All right, so that's that. And then let's just kind of quickly review compounded interest. Let's see. Let's see. I'm start saving money and or maybe yeah, like maybe let's see, saving money in a stock account. Well, anyway, that doesn't have to be a stock, just in a checking account or savings account or whatever. Account that pays interest. Let's see, the initial deposit is, let's see, $50. And let's see, the savings account, this one pays with annual interest rate of, let's see, 1.95%. By the way, that's actually really high for savings account. If you have a savings account open, you know that they usually don't pay very high interest rate. Okay, so that's the interest rate. And suppose it's compounded daily. And let's see, I want to know what's the balance after, let's see, 40 years. And I also want to know what's the effective annual rate. Okay, so this is the compounded, so it says, right, it's the interest, it says compounded daily. So every time you see the term compounded, then you should either think about the compounded interest formula or the continuous, which is the compounded continuously formula, the continuous growth formula. So one of the two. So here it says compounded daily, so we don't need to worry about the continuous model. We're just going to use the compounded interest formula. A of t equals P1 plus R over N to the NT. Okay, so that's the general formula. Now we're going to plug in what we know. It's compounded daily, so n equals 365. And the rate, the annual rate is 1.95%, which is going to be 0 divided by 1.95 divided by 100. That's a 0.0195. And then the P is the initial, the principal, the initial deposit, which is 50. So now we can take those numbers, put in there. So we get A of T, the balance. So this is the balance, all the sort of like the current value. The balance is equal to 50 times 1 plus rate is 0.0195. Now, when we, like I said yesterday, you can think about, okay, so since it's compounded daily, so we should have a daily interest rate, right? We're given the annual rate, but we need to calculate the daily rate. How do we find it? We just take the rate, divide by 365. So you can think about this is like the daily rate. Okay, so if I have a sort of this like a daily interest rate, so that means the time should be in days. So that's why in the exponent, when we talk about time, instead of having years, so T is always in years. So we need to multiply T with 365 to convert into days. So that's one way to think about it. Or you can just memorize the formula, plug in the N, plug in the R, plug in the P. So that's a compounded interest formula. And then now we can use it to solve the question. So like I said, don't worry about solving the question. Usually just try to think about, okay, what information do I have? What do I need to know? And what do I need to use, right? So now we can actually use it because we want to know the balance after 40 years. So that means T equals 40, and then we want to know the balance. So we can put 40 in there to calculate A of T. So A of T, so at T equals 40. So A of T equals 51 plus 0.0195 divided by 365 raised to the 365 times T, which is 40. And from there, we can calculate it. Any questions? Is it okay if I don't show you how to do it on the calculator? Because at this point, I mean, I'm assuming that you should be comfortable with, type this into the calculator. If you have trouble, let me know. I can probably help you with that. But for now, I'm going to leave it there. So that's the first part. Now, the second part says, okay, so that's a balance. What is the effective annual rate? So last time, if you remember, effective annual rate is sort of like the, like in reality, this is the actual annual interest rate. But what's given, the 1.95% is more like the, in theory, that's what happens. That's the interest rate. But because the interest you gained in each day actually creates more interest, even though just a tiny bit, it still creates more interest. So at the end, you end up with a little bit more interest than you should get according to the given annual interest rate. So that's why we talk about the effective annual rate. So how do we find it? So effective annual interest rate, because it's compounded daily, so it's not going to be the same as the annual rate given. So that's going to equal to this part. So drop the 50 because that's not important. Drop the 40. So we just take this part. Actually, let me take not this one. Let's take the one in the box. So drop the 50, drop the time, but keep the 365 and the exponent. So this part is going to give me the effective annual rate with a 1. So that's equal to 1 plus 0.0195 divided by 365 raised to the 365. That's for the shaded part, minus 1. So that will give me effective annual interest rate. The reason the reason we have to subtract 1 here is because in a sort of like the annual growth model, we have A of t, which is equal to P1 plus R to the t, right? So this, the part I shaded is equivalent to this part. So the one I shaded in green is equivalent to 1 plus R, but we're kind of looking for the annual rate, the effective annual rate. It's still the annual rate, so we have to subtract 1 to get the rate. So you can think about, okay, I guess that's another way to look at it is you can think about it as a 1 plus 0.0195 divided by 365 raised to the 365. This part is equivalent to 1 plus R. This R is the effective annual rate. And we're looking for the effective annual rate, so we have to subtract 1 from the left side. So the effective annual rate is equal to 1 plus 0.0195 over 365 raised to the 365 minus 1. So that's another way to look at it. Okay, let's see. Let's see, is Will back here? Ah, Will is back. Let's see. Will, did you finish the quiz?
Yeah, I got it done and turned it in.
You finished? Awesome. Okay. All right. Any other questions about this problem or anything else? All right, let's see. I think there was someone else was having a questions. Who was it? Susanna, do you have any questions?
Yeah, actually, I was kind of struggling with yesterday. So I was wondering if you could do an example of how to get a formula from a graph, because I'm having a difficulty with that.
For exponential functions, right?
Yeah.
Awesome. Certainly. So let's see. So another example. So suppose, let's say we have a graph. Let's see. I'm going to use graph paper here. All right. So suppose I have an exponential function. And it looks, I'm just going to draw it randomly. It may not be accurate, but it doesn't matter. Let's see, this point, that point is not even there. Ignore it. So let's see, I'm going to choose maybe this point. So it's an exponential function, so it goes like this. And each unit is 1, so this point on the left is -2, 1. The point on the right, this is a 2, 3. Okay, so that's a graph given, even if I don't have those points, but we'd probably be able to, pick some nice points on the graph to decide to use them instead of, guess where the X, Y is, right? Given any graph, try to find some nice points. I don't have a y-intercept because it doesn't go through a nice point there, so I'm not going to guess what that is. So let's see, those 3 points are easy to pick just looking at the graphs, and I want to find an exponential function. Find an exponential function for this graph. So it looks like I have at least 2 points I can use. So we can use points -2, 1, and point, let's see, 2, 3. So let's just see, we're going to use those points. All right, so exponential function, the general formula is f of x equals a b to the x. So a is a constant, b is a constant. We need to find those two numbers, and x is just a variable. It will always be there. So what we do is we're going to plug in those 2 points to get 2 equations. Plug in points. So I'm going to plug in the first one. So y is 1 and x equals -2. So 1 equals a times b to the -2. And to plug in the second point, 2, 3. So 3 equals a times b with a 2 in the exponent. So now I have two equations. I need to solve for a and a b. So I'm going to divide. Now, the one small trick I'm going to use here, because the first equation has a negative exponent, -2, and the second equation has a positive exponent. So I'm going to take the second equation, divide it by the first equation. So I'm going to take the second equation, divide by first equation. And the way to divide it, we're going to take the left side, divide by the left side, the right side, divide by the right side. So second equation goes on top. So 3 divided by 1, that's the left side, equals a times b squared divided by a times b to the -2. And by doing this, we can eliminate negative exponents for the b. So now what do we have? We have 3 equals the a and a will cancel, right? And the b, so now we have b squared divided by b to the -2. And if you remember, when we divide by a term with the same base, different exponent, we just subtract the exponent. So that's equal to b to the 2 minus -2. So 2 is the one in the numerator. The -2 is from the denominator. We subtract it from the 2 in the numerator, the exponent in the numerator. So if we simplify this, we get b to the 2 plus 2, which is 4. So we get 3 equals b to the 4th power. Okay, so how do we find a b here? There's two ways. One is simply just take 4th root. That's really the same, just different notation. You can take 4th root on both sides. Remember, b is positive, so we don't have to worry about negative. So we get 4th root of 3 equals b. All we can do is we can take the equations 3 equals b to the 4th. We can add 1/4 power on both sides in the exponent. That way the 4 in the exponent and the 1/4, when we multiply them, give me 1. So I got b by itself. So b equals 3 to the 1/4 power. So either notation is okay. I just want to show you both approach. So that's the b value. Obviously, we didn't really put in the calculator, right? That's fine. We can just use this expression. So let's see, we want to use this one, for example. So now what I'm going to do is I need to find a. I already have b, so I'm going to take the b, put it into the function for now. So I get f of x equals a times 4th root of, you know what, on a second note, I think, oh, it doesn't matter, I guess. I apologize, but on a second note, I think I'm going to prefer to use the second expression, the first one, but I don't think it's going to make much difference. Let me use the second expression to see if it make the answer look nicer. So b is 3 to the 1/4 raised to the x. And now I need to find a, so I'm going to use one of the two equations, doesn't matter which one. It's up to you. I'm going to avoid using negative exponents. So I'm going to use, let's see, does it matter? Probably doesn't matter. It doesn't matter. So it's up to you. I'm going to use the first equation then. So take this, put into the first equation. So I get 1 equals a times b, which is 3 to the 1/4 raised to the -2. And now I have to multiply the 1/4 with -2. A is just a, so 1 equals a times 3 to the 1/4 times -2. So that's a -1/2. And I'm going to divide that on both sides to get a. So 3 to the -1/2 divided by 3 to the -1/2. So that's a. So I get a equals 1 over, I'm going to put on the right side, 1 over 3 to the -1/2. Okay, that's pretty good. And if you want to simplify, if we divide by a negative exponent, really become a positive exponent. So that's just 3 to the 1/2 or square root of 3. So that's a value. Now we're going to take a, put into this function. We already had a b, so f of x equals 3 to the 1/2 times parentheses 3 to the 1/4 to the x. Does that help? I know I kind of like switched back and forth a couple of times in the process with different forms of different expressions. But overall, the process is, you set up two equations. You use division to eliminate usually the a, and after you eliminate the a, you can solve for b. After you find b, we can go back to find a.
Yeah, that helps. Sometimes I just miss the most basic part, like use the exponential formula and then went into that. And I just was like, I don't even know where to start. So it's something like that. But thank you.
Okay, excellent. Good. Any other questions or anyone?
Can you go over again, solving for a horizontal asymptote? I find that that's one of the things I struggle with.
Yeah, no problem. Well, it looks like why don't I is it okay if I use the quiz problem? I think everyone finished the quiz, right? As far as I know at this point, if you haven't completed the quiz, it's going to be a problem. So let me use the example in the quiz, and if that doesn't help, we can look at another problem. All right, so what's a quiz problem? Let's see. Let me find the quiz first. So the quiz is h of x is the number 2 in the quiz. We can look at other problems if you have more problems with the other ones. Let me just, why don't I just take a screenshot of this? All right, so this is a problem taken from the quiz. Okay, so here's the h of x. We have a -1 in front, and then we have this fraction, the numerator and denominator, right? So I know you probably don't have questions with x-intercepts, y-intercepts, all those, but let me kind of go through it just for practice. To find x-intercepts, we're going to set y equals 0 or set the numerator, because it doesn't matter, the denominator doesn't really make a difference here. Set numerator equals 0. So if we set the numerator equals 0, don't forget that's a negative, but it shouldn't matter at all. So we get negative x minus 2, x plus 4 squared equals 0. And then we can just multiply by -1 or divide by -1 to drop the negative. So the negative doesn't matter. So if we have this equals 0, then we have x minus 2 could equal to 0. X plus 4 could equal to 0. So we get x equals 2 and x equals -4. But we have to be careful with those x-intercepts because it decides how the graph is going to cross the x-axis, right? So we have to look at the multiplicity. So the multiplicity is given by the exponent of those factors. So that's a 1 for x minus 2 and a 2 for x plus 4. So this x equals 2 x-intercept has multiplicity of 1. And the x equals -4 has multiplicity of 2. And which tell us when it crosses the x-axis, the x at x equals 2, it's just going to be a straight line, either like this or like that. And at x equals -4, it's going to be a bounce off, either opening up or opening down. So that's finding the x-intercept. To find the y-intercept, we're just going to set x equals 0. So set x equals 0. So if we put 0 in there for x, so we get h of 0 is equal to negative. Don't forget the negative. And then 0 minus 2, which is negative 2, 0 plus 4 squared. And then we have 0 plus 1 is 1. And 0 minus 3 squared. So if we simplify this, we get negative in front. Then we have negative 2 times 4 squared, 16, divided by 1 times 9, positive 9, right? Negative 3 squared is 9. So just 9. So we end up with, we get negative, negative is positive. So we get 2 times 16, 32, divided by 9. Positive. And then to find the horizontal asymptote, I remember mentioning that we're just going to find the leading terms of the numerator, leading term of the denominator, and try to simplify from there. So for this specific example, we have the leading term, we have defined it because it's in the factored form, right? And then the denominator is also factored form. So to find the leading term, what we're going to do is we're going to take all x parts in the numerator, along with any coefficients. In this case, I'm going to carry the negative. And any exponent, that's a 1. So x and a 2. So that will be the numerator leading term. And then the denominator is going to be x to the first power x squared. So the horizontal asymptote is going to be the leading terms of the numerator. That's going to be, there's a negative in front. Then we have x to the first power x squared. The denominator is also x to the first power and the x squared. So if we simplify this fraction, the x and the x, all the x's cancels, so we get negative 1. So this will be y equals negative 1. It's the horizontal asymptote. It just means that, I don't know about the middle, but like as x goes to infinity and a negative infinity, the graph is going to approach this value, negative 1. So that's why we draw a dotted line. To find a vertical asymptote, we're going to look at the denominator. And set it equal to 0. So denominator equals 0. All right, so the horizontal asymptote, let me just write, we're going to find the leading term of the numerator divided by leading term of the denominator. And to simplify. Whatever we end up with, so that will be the asymptote. If we end up with 0, for example, if we have 1 over x, right, that's what we get after we simplify. Then we think, okay, as x goes to infinity, the denominator goes to infinity. Well, 1 divided by infinity, that should approach 0. Or if we have 1 over x squared, again, that doesn't change, it still goes to 0, right? But if we have x over x, then that becomes 1, so that 1 will be the horizontal asymptote. Or if we have 5x over 2x, simplify, we get 5 over 2. So that will be the horizontal asymptote. So it depends on what we get after we simplify. All right, so vertical asymptote, we're going to set the denominator equals 0. So x plus 1 equals 0, x minus 3 squared equals 0, x minus 3 equals 0. So we get x plus 1 equals 0, x minus 3 equals 0. So we get x equals negative 1, x equals positive 3. Again, so here we have to go back to the factor form to look at the exponent for each factor, because that's going to tell us what kind of, how the graph is going to be like at those vertical asymptotes. At x equals 1, we get exponent 1. At x equals negative 1, we get exponent 1. X equals 3, we get exponent 2. All right, so this one has a x plus 1 to the first power. So that means at this vertical asymptote, we're going to have a divergent graph. And And at x equals 3, because we had x minus 3 squared, at this vertical asymptote, x equals 3, we're going to have the 2 tell us it's going to be convergent graph. Which means that either both sides are going to go up or both sides going to go down. Divergent means one side going up, one side going down. All right, Alia, I think I saw you had your hands up. Do you have a question?
Yeah, I just have a quick question. For the horizontal asymptote, can you divide the first like leading coefficients and just find it? Like, I forgot how you do that, but I think I heard that someplace. I don't know.
Yeah, only if you have the same, only if the leading terms have the same exponent for x. For example, let's say I had a 5x divided by 2x. If those are the leading terms, we just, obviously we cancel the x, end up just finding the coefficient 5/2. So that will be the horizontal asymptote.
Okay.
But if we have cases that, let's say, the power of the numerator, the leading term of the numerator, and the power of the leading term of the denominator, they're not the same, then simply taking the leading coefficients doesn't give us the correct horizontal asymptote. For example, if we had, let's say, the numerator at the end give us 3x squared, the denominator at the end give us 4x cubed, right?
Yeah.
The 3/4 is not the horizontal asymptote, because if we simplify all the x's, we still end up with 3/4x.
Okay.
As x goes to infinity, the denominator is going to go to infinity. The numerator doesn't change, right? 3 doesn't change. So 3 divided by infinity is going to go to 0.
Okay.
Right, and the same thing as x goes to negative infinity, we end up with a 0. So the horizontal asymptote is actually 0. It's not a, well, anytime there's an x remaining after we simplify in the denominator, it's always going to be 0, because the denominator always going to go to infinity if there's an x remaining.
Okay.
All right, good question. Yeah, good point.
So if the leading term, if the power is higher in the numerator, then there's no horizontal asymptote present, right?
Correct. Actually,
Okay.
that's a very good point. We didn't talk about it, but I'm going to tell you now, but I would say don't worry about it. It's not going to be on the exam. It's actually very interesting. You brought this up. So let's see. Let me give me some space. So suppose we have the leading term of the numerator and the leading of the term of the denominator. The numerator has a higher exponent. Let's say 3x force divided by 2x squared or something, or cube. We simplify, we end up with 3/2x remaining. And this one actually tells us the end behavior. It's not called a, it's actually called a slant asymptote, because this says, okay, as x goes to infinity, the y is going to follow this line 3/2x. So y is going to go to infinity. As x goes to negative infinity, the y is also going to go to negative infinity. So the graph, instead of having a horizontal dotted line, the ends follow this dotted line, not like this anymore. The graph actually follows a straight line, 3/2x. So the ends going up like this at the end. Does that kind of help?
Do we do anything with this slant asymptote?
No, don't worry about it. So like I said, I just want to show you, it's kind of behaves like a horizontal asymptote. It's just that at the end, the arrows don't go horizontally. It's kind of like going up and down. But it's not going to be on the exam. I just want to show you this. That's a good point. It's a very good example. So the horizontal asymptote also calls the process to find a horizontal asymptote using the leading terms. It just gives us the end behavior of the graph, like what the two ends look like on the left and right. Obviously, we can make it more interesting, right? Suppose the leading term is 3x to the fourth. the leading term of the denominator is 2x squared. And if we simplify, we end up with 3 over 2x squared. So that means it's not called a slant asymptote. So the end is going to behave like this quadratic. So it's going to follow this path. At the end, the middle, I don't know, but at the end, it's both sides is going to go up. All right, anyway, so that's enough distraction. Good point. So now we have the vertical asymptote and we have the horizontal asymptote, x-intercept, y-intercept. We can graph it. So let's see, I'm going to graph it. So let's just draw a graph here. So let's see, we have x-intercepts 2 and a -4. So let's call this 2, call this -2, -4. And I know that at x equals 2, it's going to cross like a straight line because multiplicity is 1. So this is a straight cross. And x equals 4 is going to be a bounce off, like a parabola, because it has a multiplicity of 2 if we go back a little bit, right? And let's see, y-intercept, which is 32 over 9. At this point, it doesn't matter. Just see, okay, this point is 32 over 9. It's positive. Let's just say this is 32 over 9. Horizontal asymptote is y equals -1. So we're going to say, okay, that's, oh, wow. We kind of just have to be a little bit more careful. 32 over 9 is about 3 point something. So I'm actually going to move it up. So that's, so -1 is somewhere here. I don't really worry too much about the scale on the y-axis. So negative, well, this is a y equals -1. This is a horizontal asymptote. Y equals -1. And that just means that the middle, I don't care, but at the end, the arrow should be sort of become flat, pointing in both directions. And the vertical asymptote, I have it at -1 and 3. So let's see, -1. It's here. So that's a vertical asymptote. And the 3, which is about here. And at this x equals -1, the graph is going to be divergent. And at x equals 3, the graph is going to be convergent. And remember that we cannot cross vertical asymptotes. It's okay to cross horizontal asymptote, just not vertical asymptote. And we cannot cross the axis if there's no point to cross. All right, so now let's graph them. So we can either start from the left or right. If we start from the left, we take the tail of this arrow and we move towards the right. We cannot go up because there's a, oh, wait a minute, I did it right. Sorry, I forgot to put this point here at -4. So that's the x-intercept. So if we have x-intercept, we must use it. So it's a bounce off. The arrow is below that point so that when we start drawing, it's going to go, it's not going to go past it, right? Because it has to touch the x-intercept. So it's going to go up, go to the x-intercept. When it touches, it has to bounce off. So bounce off, come back to the same side below the x-axis. And now it cannot go back up again because there's no x-intercept to pass. And there's a vertical asymptote right next to it. So it cannot go up because that's not right. It has to stay below the x-axis and it's sort of being blocked by this vertical asymptote. So that's this piece. And it's divergent. The left side going down, the right side must going up. So the right side has the arrow going upwards. And if we take this arrow and try to draw it, it cannot cross the x-axis before it reaches the y-axis because there's no point there. You know, there's nothing to cross. So we have to take this arrow and just make sure it goes through this y-intercept. And after it passes the y-intercept, there's the x-intercept waiting. So it's probably going to go down through the x-intercept like a straight line. After it passes it, it cannot go up. There's no point there to pass. And there's a vertical asymptote, so it's just going to continue. And this second vertical asymptote at x equals 3 is the vertical asymptote where the graph will be convergent. So the left side going down, the right side will going down as well. If it going down and we take the tail and there's no point on the x-axis to pass, so it doesn't go up. So eventually it has to be flat. So we just draw it like this, connect it with the other arrow waiting for it. All right, does that help? I know there's quite a few questions with horizontal asymptote, vertical asymptote, or even just rational functions in general. Any questions about this example?
Can you just explain the negative a little bit better, like in the original function? I'm just like confused as to how it distributes. Like for you got 32/9. Was it like -2 and it was the 2 was the only one that got the negative?
Correct. So this x, right. So this negative in front of the fraction that could go to the numerator or the denominator, right? Doesn't matter. So this negative and this negative of the -2, when we multiply them, it become a +2.
Okay, so then why is it not negative times -1 and then -9?
I see. That's a good question. So with a negative in front of a product and the division, well, let me write down two things. If we have a negative, let's say -2 or -1, doesn't matter. A negative in front of a parentheses with a addition or multiplication, something like this. That's the case we distribute the negative in there because it's a -1 times whatever in there, right? So that's going to be -1 times 2, that's a -2, plus -1 times 3, so -3, so that's a -2 minus 3. That's distribution there. But if we have a negative in front of, I don't need the parentheses, in front of the multiplication, 2 times 3. Now we don't distribute the negative here because the negative is actually a multiplication. It's the -1 times 2 times 3. So when you have all three terms that are multiplying, you don't distribute the negative. You can take the negative, multiply with 2 first, or take the negative, multiply with 3, but you don't distribute the negative. So you can write this as -2 times 3, or you can write it as 2 times -3. But it's not distributing the negative. It just depends on which number we multiply by the negative first. So that's when we have multiplication. We just take the number, take the negative, multiply with one part, not everywhere. With the example, we had a negative, and in the numerator, we have -2 times 16, then we have 1 times 9. Again, this is like a -1 times a fraction, right? But that's a product in the numerator and denominator. So just, you have to think about division as a multiplication as well. So just a whole bunch of multiplication. So we can do is we can take the negative in front, multiply with the -2 first, or we can take the negative, multiply by any number, but we cannot distribute it into every term. So what I did is I multiply with this 2. So -1 times -2 give me 2. So that's going to be 2 times 16 divided by 1 times 9. But if you say, okay, can I take the negative multiplied by 16? Sure. If we take the negative multiplied by 16, we get -16, but everything must stay the same. Because there's no addition and a subtraction, there's only multiplication and division. So the negative only being multiplied once by one of the terms.
Okay, that makes sense. So it's like once you multiply it, it's gone.
Correct. It's being
Okay.
it's being used up.
Okay, because that was just throwing me for a loop. So thank you.
No problem. Yeah, I always tell myself, okay, distribute only if you have something multiplied by an addition and a subtraction. Good question. Any other questions? Let's see. Any other question about this example, actually? All right. Let's see. I know there's 2 more questions. Let me ask you, should I spend time on the first example on the quiz, which was this quadratic function, find the x-intercepts, find the vertex, find the domain and the range. Should I spend time on that? Let me know if you want me to spend some time on it.
I would like if you could do the third one on the quiz.
Absolutely, absolutely. I can work with the third one. But before I talk about the third problem, any questions about the first one? So let me take a screenshot of this. Well, think about it. If you want me to go over number one, I'll go over it.
I mean, you might as well just do all of them.
Okay, sure.
Yeah, that's fine.
Not a problem. All right, hold on, let's see. Not a problem. Well, let me go through number one then, and then I'll go to the last one. All right, so this is number one. It's a quadratic function. And we're going to find the x-intercepts. So that will be setting y equals 0. So it'll be 0 equals x squared minus x minus 12. Now, you could use quadratic formula, but I'm going to try to factor this, which is going to be, so we have x squared, so each parentheses get an x, and I need two numbers that multiply, give me negative 12, and when I add, give me negative 1. So product is equal to negative 12, and the sum is equal to negative 1. So, okay, let's think about, okay, 3 and 4, right? Obviously, 12 is 3 times 4, or 2 times 6, but that doesn't work. 3 times 4, okay, maybe work. 1 has to be negative because the product is negative. So maybe negative 3, positive 4, but that sum doesn't work, right? So, okay, let's switch around. So 3, negative 4, that works. The sum gives us negative 1. So we get x plus 3, x minus 4. And that's equal to 0. So that means every part here could be 0. So x plus 3 equals 0. X minus 4 equals 0. So we get x equals negative 3, x equals positive 4. So those are the values that will give me x-intercepts, which is negative 3, 0, 4, 0. Good. All right, finding vertex, right? If you remember finding vertex, the vertex is for parabola is on the axis of symmetry. The vertex has a x coordinate, which is negative b over 2a. So we can find this first and then use it to find the y. So to find the vertex, we're going to find axis of symmetry first. Negative b over 2a. And the b here is negative 1. You have to take the negative when you write down the a, b, c from the formula. So b equals negative 1, c equals negative 12, a equals 1. So axis of symmetry, negative b over 2a, so it's negative 1 over 2 times a is 1. So we get positive half. Negative is positive in the exponent, positive half. So that's the axis of symmetry. It's also the x coordinate of the vertex. And we have this x coordinate. Now we can find the y coordinate by using it in the function. So we're going to find y. So f of 1/2, take 1/2, put in there for x, which is 1/2 squared minus 1/2 minus 12. And if we are careful here, so we get 1/2 is squares of 1/4 minus 1/2 minus 12. So that's going to be, oh my goodness. So 1/4 minus 1/2. I'm just going to common denominator for all of them. So 1/4 minus 1/2 times 2 times 2. For numerator and denominator, minus 12 times 4 over 4. So it turns out that's going to be 1/4 minus 2/4 minus 48/4. So 50 minus 1, negative 49 over 4. So that's the y coordinate. Then the vertex is going to be 1/2 and negative 49 over 2 over 4. So that's a vertex. And then if we want to find the domain and the range, well, this is a quadratic function, right? So the x could be any number. So the domain will be all real numbers. So from negative infinity to infinity, and the range, we have to think about the graph, the vertex. So the vertex is the lowest point on this specific graph because it opens upwards. So the lowest y value is going to be negative 49 over 4. So the range is going to be negative 49 over 4 to positive infinity, including this negative 49 over 4. All right, so that's the domain and the range. So the range, you kind of have to know where the vertex is, right? The lowest value or highest value in order to write down the range. Any questions about number 1 here? Right, number 3. All right, number 3 says the graph for the polynomial function is given, and we're going to find a formula for this function with the least degree possible. I'm just going to take the graph, not the whole problem. So this is number 3. And we want to find a polynomial function for this. And okay, so let's see, what do we know from this graph? We know that there's an x-intercept at -1, and it's a bounce off. And we have x-intercept at 2. It tells you if past the graph looks like a chair. If you remember, if it's a chair shape, that means it's going to have a multiplicity of 3 or higher. But if we look at another x-intercept 3, so the graph looks like it's crossed it like a straight line, right? It's not a chair shape. So that's going to have a multiplicity of 1. So let me write down. So here we have x-intercepts. X equals -1, looks like it's a bounce off. And x equals 2, it's a chair shaped. X equals 3 is a straight line, straight cross. And we also have this y-intercept, which is 0, -12. And it's a polynomial function, so we're going to write the function as f of x equals some coefficient a with a whole bunch of parentheses with the correct exponent. So the x-intercept -1 with a bounce off there, so that's going to be x plus 1, so x minus the -1. So x plus 1 bounce off, it's probably going to be a 2 or 4, but we're going to look for the least degree to put a 2 there. So that will give us a bounce off. And then x-intercept x equals 2, so that's going to be x minus 2, but it's a chair shaped when it crosses the x-axis. So that's going to have a power of 3 or 5, but we're going to use 3. And x equals 3 is a 3 cross, so that's x minus 3 to the first power. So that's sort of like the beginning part by putting in the x-intercepts. And the next, what we're going to do is we're just going to solve for the coefficient a. We don't know what it is, but we have the y-intercept to use. So we're going to put 0 and the -12 in there. So we get -12 for y equals a times 0 plus 1 squared times 0 minus 2 cubed times 0 minus 3. And simplify the right-hand side a bit more. So that's a times 1 squared is 1. -2 cubed is -8. And times -3. We can multiply those 3 numbers together. So that's a times negative is positive. 3 times 8 is 24. And now we're going to divide by 24 on both sides. So we get -12 divided by 24 equals a. Simplify the left-hand side. So 12 goes into 24 twice. A equals -½ And now we can use this in the function that we began with. So that's f of x equals -½ x plus 1 squared, x minus 2 cubed, x minus 3 to the first power. So that's number 3. Any questions on this? Sometimes, it's probably not going to give you a graph. It might just say, okay, this function, this polynomial function has a 0 at x equals -1 with multiplicity of 2 at x equals 2 has multiplicity of 3 at x equals 3 has a multiplicity of 1 and a y-intercept. Write down the polynomial function. It could be like that.
I don't really have any questions about the problem itself, but in both 2 and 3, I made like minor mistakes that then kind of snowballed into a bunch of wrong answers. Is that going to be kind of considered on the quiz when grading, I guess?
Absolutely. So
Yeah.
I totally understand. So let's see which one. Probably number 2, for example. Let's say number 2, you did everything correct. The process is correct, right? But let's say you find the y-intercept incorrectly. And let's say you end up with a negative y-intercept. And that's definitely going to affect the graph. But I will definitely take a look at that. I'll probably just see the wrong y-intercept you used and see if you try to graph it correctly.
Okay, yeah, because especially with the distribution, I messed that up. And then also when graphing it, I got the horizontal asymptote as -1. So because I couldn't cross the x-axis, my graph just looks nothing like that.
Yeah, so. I totally understand. As long as you show the work, and I'll take a look and try to grade it accordingly.
Okay.
Yeah. I think the graph for number 2 is only 2 points, if I remember correctly. 1, 2. Yeah. So for the graphing part, probably only 2 points or 3 points. The rest is like 1 point for each x-intercept, 1 for the y-intercept, 1 for the horizontal asymptote, 1 for each vertical asymptote.
Yeah, I especially on 3, my dumbass.
No problem. Yep.
I thought that the edges, I treated them like vertical asymptotes, so my equation's actually over. Over x plus 2 times x minus.
Okay.
4.
Okay. I
so
think
I fucked up.
Yeah. I'll take a look. I think as long as you get the numerator right, should get most of the points. All right. Any other questions? I haven't given you a break yet, but I don't imagine we're going to stay here until 8:30. So any other questions that you have on your mind? No. All right. Like I said, I probably said it too many times, but I'm just going to say it one more time. The exam will be available at 6:10 on Monday, and you should have enough time if you have accommodation and just calculate how much time you need, and just finish it in time, right? And to be honest, you guys are all college students, or most of you are. Maybe one of you is not. And from now on, right, like, this is your life. You kind of have to take control of how things goes. Just do your best. That's all. If there's some difficulty, like you're going through, rough weeks or something like that, let me know. I'm going through a difficult time at home too, with all this stuff going on. Too busy, and I totally understand. For some, if you just say, okay, I'm super busy with work, and I know quite a few of you actually working in the summer, and just need more time. I definitely understand that. Just let me know, but keep in mind, you don't want to be like, oh, I'm working every day. I just don't have time to do any work, and all the, all the homework pile up, and at the end you're not going to finish it in time. That's not going to help you in any way. And remember the deadline that this class ends on August 25th or 25th. Anyway, that Friday, I think might be 26th. So the last homework is due that Friday, and I have to submit the grades that same day. so that homework cannot be delayed. So you have to finish that homework in time, and anything before that, you have to complete it in, before I calculate the grades, right? So just keep those in mind. If it's totally fine if you say like, oh, I just need a couple more days, that's fine on homework. But you probably don't want to delay the exam or quizzes in the future, because if you cannot take the quiz on the quiz day, that's fine. But just try to take it the next day with me, and that way, like we don't drag that on for too long. All right. Any questions about, just in general about the quiz on Monday, about the exam on Monday, or just in general about this class, or about, problems that you might have regarding the exam? Anything?
Quick question.
Yep.
Do you mind just going over the synthetic division a little bit?
Sure. Yep. Let's see. Good question. I almost forgot about it. So synthetic division. So let me just make up an example. I to be honest, don't know if it works. Well, it's fine. Doesn't matter, right? If we have a remainder, then we have a remainder. So let's see. We have x to the 5th power minus 4x cubed plus 3x squared minus 2. This polynomial is divided by, let's see, x plus 2. And it only works, so synthetic division only works if you have a factor like this one, which it's called a linear factor because it's a 1 times x plus or minus a number. So it's x to the 1st power plus or minus a number. It works. Okay, so we're going to set it up. We're going to find all the coefficients. If there's any term that's missing, we're going to add a 0. For example, we begin with x to the 5th. So we don't have x to the 4th, so we're going to add a 0 x to the 4th. And we have x cubed. We have x squared, but we don't have x, so we're going to add 0x to the 1st power. So those two parts, we have to put a 0 there. So let's write down the coefficients. 1 from x to the 5th, a 0 from x to the 4th, -4 from x cubed, 3 from x squared, 0 from the x term, and a -2 the constant term. And then the number I'm going to put on the left of the synthetic division is opposite from what this parentheses says. So opposite. So x plus 2 means that we're going to put a -2 here. All right. So it works. It's always down, up, down, up. So we take down the first number directly. So that's a 1. And then we're going to take this 1 and then the -2 on the left. And to get a number on the, like going up, put below the sort of the next position, below 0. So 1 times -2 is -2. And now we're going to add. So keep in mind that it's always addition. So 0 plus -2 is -2. And then now we're going to go with this -2 and this -2. We multiply them and they go up. So when I see add, we actually put the number below, right? So that's a down. And now we're going to go up. So 2 times -2 is +4. Put it there. And now we're going to add and put the number below. So 4 plus -4 is 0. Well, that's good. And then I'm going to take the 0 and this -2, multiply them and put it in the position next to it. So up. So -2 times 0 is a 0. Okay, that's fine. We're going to add again. So 3 plus 0 is 3. And now we're going to take the -2. We're going to multiply with a 3. So that's going to be going up. So 3 times -2, -6. And now we're going to add 0 plus 6. 0 plus -6 is -6. And now we're going to take the -2 and -6, multiply them and put it in the next position. So going up. So -2, -6, +12. And then we're going to add -2 positive 12, that's a positive 10. So this will be my remainder. But the idea is always down, up, down, up. The first number doesn't change. You always bring it down directly. And then, you know, the other numbers, you multiply, you add, multiply, add, and continue. So that's the remainder. Sorry, go ahead.
Oh, so the first number doesn't change, you said, so you just brought down the 1.
Exactly.
Okay, and you multiplied -2
With a 1. Yep,
Okay.
-2 with this 1. And then it goes to this sort of like the next position.
Okay, then it's just up, down
Yep.
throughout.
Yep.
Okay.
Yep.
Thank
Yeah, so
you.
good question. So the first number never changes because we divide by x plus a number, right? So if you think about whatever we begin with, we divide by x, we kind of just keep the coefficient. We don't change the first one. Yep, good. So now what we do is we have to write down the answer correctly, right? So we begin with x to the 5th power. So at the end, the 1, -2, 0, 3, -6. So that will begin with x to the 4th power, x cubed, x squared, x, and the constant. So we're going to write down correctly. So it's 1 times x to the 4th, so x to the 4th, -2 times x cubed, so -2x cubed, 0 times x squared, that's a 0. We don't even have to write down the 0x squared. And then positive 3x, so plus 3x, and -6 coming down as a constant. And the remainder, we're just going to write as 10 divided by whatever the divisor, x plus 2. So this will be the way to write it, the quotient with the remainder. Again, you don't have to write this as 0 x squared. All right, good question. Any other questions? One last comment. I think you should, well, just advice. Definitely. So this is what I'm sort of picturing. For the exam, you know, we have 2 quizzes, right? For the exam, it's going to cover everything, definitely, but it's not going to, you know, have a focus on the stuff that already being quizzed. I'm not saying like the problem we saw on quiz 1 is not going to be on it. It's still possible to be on it, but maybe one problem from the material on quiz 1, maybe one problem from the material on quiz 2, or maybe 2 problems there because I like those problems. But you know, like the stuff that we haven't had a quiz on, like compounded interest, compositional functions, inverse functions, you know, like the more recent stuff that we haven't had a quiz, or even like, you know, long division, synthetic division. That might be like questions on those, because I do want to assess that, you know, you have a good understanding about everything we talk about so far. So like the stuff we talk about, like a linear functions, parallel perpendicular lines, that might be one problem on those topics. Quadratic polynomial rational functions, there might be one problem on it. It's probably not going to be 5 problems on those, right? Just 1 or 2. And then there's the other sections that we have not had a assessment on, like compounded interest, exponential functions, inverse functions. You know, we might have questions on each of those. So just keep that in mind. All right, any last call? Any questions, final questions?
If we do have more questions before the quiz, when did you say your office hours were?
Good question. I don't even remember. I think I have one tomorrow from 3 to 5. I don't know if I'll be around. Just send me an email, say like, oh, can I come to talk to you for with questions tomorrow? I think that will be the best time. And let's say Monday, I think also have office hours, don't I? 3 to 5. Yeah, Monday might be a good time as well.
Okay.
Yeah.
Thank you.
Yeah, no problem. And if neither time works, just say, oh, can you, meet me at this time? And if I'm free, and I'll probably say yes, but it depends on my schedule.
Okay.
Yep, no problem. All right, so all of those are good questions. You guys have very good questions today, and And anything else? No. All right. I would say, when you study, obviously, like, look at the notes. You wrote down the problems, the examples I go over in lectures. Homework problems, you just look through them, make sure every problem makes sense, and then keep in mind that well, at least this is my intention. Maybe it didn't reflect well on quiz 2. I do not have intention of giving you like a challenging questions. I tend to at least give you problems that's not more difficult than the problem we go over in lectures, right? It should be like, sort of medium level, some easy problems, some medium level problems. That should be kind of like the expectation for problems on the exam. I want you to do well. I don't want, like to kind of like give you challenging questions so that none of you do well on it. That's not the intention. So just study, look at the examples we go over, look at the concepts, make sure they make sense, and I think you should be okay. All right, I think I said enough. So I'll stick around for a bit longer. So just in case if some of you have questions and didn't want to ask in the group. But other than that, I'll let you go. And good luck. And I'll see you, may or may not see you on Monday.
Thank you.
All right, take care.
Thank you.
Yep. All right, bye-bye.
All right. I
right.
didn't want to sound stupid. I just wanted, I had one more question. I don't know if it'll be on the exam. Treating I as a number. So if we have a 0 or say an x-intercept, and we can only factor down to x squared plus 25. So I really don't understand how I works.
Okay, no problem. I'll help you. That's actually good. I don't think we'll be on it, but I think it's good to let you know. I'll explain to you. I think it's good to know it just for the future reference.
Because the other thing, sir, I don't know if it's just the way that the homework is worded, or if it's just the questions from the book. I probably put in 3 or 4 different answers before I get the right answer on the homework, simply just because I don't know what they're looking for, and it's really hard to kind of put in the correct notation on the computer. So I didn't mean for you to I didn't want you to think I was getting like snippy about the homework. I was just like, man, like what am I doing wrong? This is I spent like a whole ass day. It was my wife left for work and came home from work, and I was still doing homework. So I just wanted to let you know that. But so
yes, I have to apologize for the homework. It's just that the website is set up in such a way that it only takes the answer in certain way. For example, if a question asking you for x-intercept, you solve for x equals 5, and we all know that's what the x coordinate of the x-intercept. Normally, we would take that as okay, this person knows x-intercept is at x equals 5. We accept that as the answer. But for the program, it actually looking for 5, 0 as a point. It's so that's kind of a difference.
Well, especially the how do you word it, the stepped equations, where you kind of go through the whole thing. I mean, sometimes it's so simplified that I'm 2 steps ahead putting the answer in, and they're like, no, like we literally want you to put g of x, and I'm like, okay, like come on, guys.
Exactly. I totally understand. I think for homework 3, I try to avoid those problems because in one sense they're good because they kind of show you the step by step how to solve it. But then you're right, they're just so tedious. Like you have to put this in there. I mean, I just at some point I just didn't like it. But
I'm over here like, man, that's only 1 point out of 35. Like, I'm like,
is it really worth it, right?
Yeah.
But I understand what you're talking about. you're not the only one here. That we have, students always find it frustrating working with WebAssign, but it's kind of nice in a way because sometimes you can click on the tutorial.
Yeah.
They give you more examples to look at.
I certainly understand the application of it. I
Right,
mean,
yeah.
most of the tutorials help. The questions I spend the most time on are the ones that, like I said, are stupid. And it doesn't even have a tutorial for what I'm
Right.
looking for because it's so simplified and they're just not very direct about asking for that,
Exactly.
So
Yeah. Right. Yeah. Hopefully we'll get better.
it will.
Maybe become an expert with it.
I'm trying. So I squared is -1.
Correct.
And negative I squared is 1. Right? Or no?
Yep. Negative
I squared is
wait a minute. No, negative I squared is not 1. So, well, let's begin with I. So
I was going to say that's neither here.
It's square root of -1.
Okay.
That's just a definition, right?
Yeah.
Give me a second.
I can turn my camera on too. It's just my laptop. I treat it like a desktop, so it's off to the side. So like in class, I'm looking at my monitor and not my laptop. So. Oh, no, I can't hear you. But I mean, honestly, especially if it's so simple about I, so I equals square root of -1. I squared equals 1.
Right.
So I guess, I mean, even that is kind of enough information to work off of. I just, on that specific, problem that we had where we could only factor down, it was plus or minus. Yeah, it was the x-intercept is plus or minus 5i, and I was just like, I do not fully understand that. So
okay, no problem. So I squared is -1.
Yep.
And then I cubed, you can think about as I times I squared.
Okay.
Which is I, well, we just leave it I, it's not square root of -1. So I times -1, which is -I. And
okay.
to the fourth power, we can think about as I squared times I squared. So that's -1 times -1.
Oh.
Right?
Yeah.
So actually +1. So I to the fourth power is +1, not -I squared. Now, the reason there was -I squared. Oh, you probably think about -I squared.
Maybe, yeah.
If you think about a negative by itself and then I squared, that is negative of -1. That's +1. You were correct there. But if -I squared, well, if it's a negative squared, it doesn't matter. It still becomes positive. So that's the same thing as I squared, which is -1.
Okay. All right. Yeah. So I guess I'm seeing a trend. Even exponents.
Exactly.
Yeah. Okay. All right. Yeah. And yeah. Okay.
All right, with this problem, you have x squared plus 25. And suppose we're looking for the x-intercept or looking for the zeros, right? We have equal 0 at some point, so that's what equals 0.
Yeah.
And we just minus 25, so x squared equals -25. Then we take a square root on both sides.
Okay.
25. But generally, we add plus minus.
Okay.
So plus minus. Now, this is a square root of -1 times square root of 25. So that's where the I comes in this part because of the square root of -1.
Okay.
Plus minus 5i.
No, that makes pretty damn good sense. All right, cool. Yeah, like I said, it's I'm knocking the rust off. I was good at math once upon a time, but
it's going to come back. Don't let it beat you. It's going to come back.
Yeah. Well, in the quiz, like I asked you with the grading, I was in like panic mode for time, and I still didn't even make the time. So
worry about
you know, I'll just make sure that I handle that better in the future.
Yeah, exactly.
So,
Like
all right.
I'm pretty, you know, try to relax as much as I can. But yeah, just let me know. We'll work things out.
Awesome. All right. Well, thank you. Thank you, sir.
All right, no problem. All right.
All right. Have a good day. Hopefully all your stuff works out.
Oh, just things on top of things. Too much going on.
That's how it works.
Right.
That's exactly what's happened to me. It's just piling. But
Exactly. But it will be fine.
yeah, we'll get through it. All right. Thank you, sir.
All right, no problem. All right, see you, Ryan. Take
All
care.
right, bye.
Bye-bye.